Good morning, everybody. This is a live extreme weather briefing today as we have a lower end tornado threat. Here you can see that supercell that was to the southwest of Tupelo yesterday. Little wall cloud tucked right up against the rain shaft. You can see that little RFD structure starting to tilt up over top that stable air. So you could definitely tell that this storm was beginning to battle with that low level stable air to the north of that boundary that was reinforced by that morning convection that we were breaking down yesterday, that fire hose that was coming right into Tupelo there. This storm, I think, was going to be the big time tornado producer as it lifted northeast through northeastern Mississippi and northwestern Alabama. If that big time rain up there didn't cause that stable air to be much more substantial to the northeast. And there you can see that QLCS type of a regime that went off toward northwestern Alabama, producing that tornado right in Winfield, Alabama, came right through downtown. You can see the lightning illuminating that wall cloud off to the northeast, shot with the Dominator drone, panning off to the west. You could definitely see that sunset happening as well. But that Tupelo storm there, if that stable air, if there wasn't as much rainfall tomorrow morning just streaming right into that Tupelo area, then that thing would have likely been a prolific tornado producer as it moved just to the east of Tupelo. And then another storm just to the south of that, the one that you're looking at here, ended up moving off to the northeast and eventually produced that Winfield tornado yesterday. And today there is a lower end tornado threat across the Mid-South. And I'm going to be targeting this lower end tornado threat. I do think that near central Alabama is where I am going to be targeting. There is a subtle little surface perturbation right along this boundary. Just a little subtle surface low that's located near the Jackson area. A little bit greater instability starting to surge up ahead of that feature. So that's what I'm going to be targeting today. And I'm also going to go do a damage survey there on I-65 southeast of Calera. Looks like probably an EF2 tornado touchdown there based on that dual pole data. Sam Emerson showed that debris was carried up above 12,000 feet as indicated by radar. That rotational velocity just greater than 60 knots, and it was really close to the radar as well. But it looks like that was probably an EF2 tornado that touched down right along I-65. Thankfully, impacted this rural terrain to the east of I-65 here. It was just to the south of that red road, eventually crossed the road as it turns off to the southeast, and then it lifted just before coming into some of those more populated areas to the east-southeast. But I'm going to be going to inspect some of that tree damage there from that EF2 tornado, I-65 off to the east-northeast. Flash flood warnings continue as you have a fire hose here, one after another, more storms upstream, and this is the same area that got big time precipitation last night as well. And this boundary isn't going to be advancing very fast. So I'm going to be looking for those storms that are able to peel off that boundary, have a bit more of an east-southeasterly storm motion. Once that propagation dominates over translation just enough to peel those storms off that line, maybe they could have an outside chance at a tornado threat. We do have this severe thunderstorm warning just to the south of Atlanta. Maybe a little bit of a supercell structure here. You can see a bit of an appendage, some inflow streamers coming into this storm. Definitely some damaging winds likely with this storm as it moves off to the east-southeast. And there is a chance that as this moves east-southeast, it could gain a low-end tornado threat, but I'm not really seeing that in the near term. Mostly outflow here, Whippoorwill Ridge up there right along Highway 85 south of Fayetteville. Could get some damaging winds, but it looks like probably more like 50 to 60 miles an hour within this. A bit of an elevated mesocyclone there as that moves off to the east-southeast, so that open warm sector. But you can see this flash flood warning. Douglasville includes downtown Atlanta as well, that flash flood warning. And definitely during the morning commute could be some standing water at times out there. Let's look at some of this storm total precipitation over the Atlanta area. Some reds definitely, 2 to 3 inches falling over the Atlanta metro from this event. Greater amounts further west, out near Bremen, Buchanan, Tallapoosa out there along the I-20 corridor, and especially just north of I-20 is where some of that even heavier rain happened to fall. But those flash flood warnings are going to continue through the morning hours. And my plan is to head towards central Alabama. I'm going to get back south of this convective line. But look at this precipitation. Storm total precipitation out here in the red, several inches, 4 inches of precip. Heading right into where just to the north of where that tornado passed. That tornado passed just to the south of Calera Alabama, touchdown right along I-65. We were live when that happened too, right when that touched down, and that continued to move out to the east-southeast. So I'm going to go sample that damage path, and also I'm going to maintain my positioning for the big trough ejection on January 1st, and I still think that's going to be a pretty substantial event. We can break down those models. We do have some new models that are out now as well. So let's break down the models for January 1st. Looks to be like more of a mega-trough ejection as well on January 1st, a tandem trough ejection. Not dissimilar from that December 10 and 11 event. You never like to make comparisons to those really high-end events that happen, because people think that the exact same thing's going to happen with those quad-state supercells. But the similarities meteorologically with that event are just that it picks up that closed upper low off of California, off of Baja, and then it pivots it, basically pivoting it ahead of that trough. I'm going to show you that trough ejection right here on the 6Z GFS at least. Probably should we'll also look at the European model. The 12Z isn't quite coming out yet. But there you can see that closed low off of California. Here you can see your parent system coming into the Pacific Northwest. A ton of similarities with that December 10 and 11 trough ejection, where you had that parent wave coming into the Pacific Northwest, textbook La Nina type storm system. And the timing is just perfect to where it could pick up this trough and slingshot it out ahead of that trough and over that warm sector. And it moves across the Mexican plateau here as well, picking up some dry air in the mid-levels of the troposphere. And then it drags that drier air over top that moisture. And look at this anticyclone that's in place over the eastern Gulf of Mexico in the southeast. That has been helping to maintain that reservoir over the Gulf of Mexico of 70s dew points, above normal sea surface temperatures in the Gulf of Mexico as well. And that coupled with the cold water in the northeastern Pacific with a year 2 La Nina in the Pacific is really the perfect storm for wintertime tornado outbreaks. So that big reservoir of moisture sitting down here. So here you can see our old Baja system that ejects to the east of this trough as more of a jet streak, very similar to what happened on December 10 and 11. Not quite as high amplitude, but boy, look at that low-level jet nosing up into southern Kentucky, central Tennessee, Mississippi, Alabama here, and that's at 18Z on the first. 18Z, this is only the 6Z GFS, and the European model even has a more backed low-level jet. And then it peaks. Look at this 70-knot low-level jet surging up into central and eastern Kentucky once again. Anywhere within this axis of a low-level jet is going to have a substantial tornado potential. Long-track tornadoes, prefrontal confluence bands of supercells through that warm sector appear likely. Going towards 0Z. Trough still hasn't quite ejected. Still going to have these supercells racing up through northern Alabama, eastern Tennessee, eastern Kentucky. And then the low-level jet axis begins to consolidate to the east of the Appalachians as well. And I do think that there is a decent chance of some eastern U.S. severe weather as well as that squall line moves over the southern Appalachians. That low-level jet accelerates to the east of the Appalachians as well on the 2nd. But it looks like it might be a little bit too fast, at least based on this run, to generate that big instability. But you still have that axis of a low-level jet hanging on the central and eastern Carolinas. That's still right at peak heating. This is 18Z about midday on January 2nd, when there is a potential of some severe weather and a squall line that's going to be approaching the eastern North Carolina, South Carolina area, southeastern Georgia. We'll just have to keep an eye on that as well. But I think there's going to be a big tornado outbreak, it appears, on January 1st across the Mid-South. It's a lot of similarities to that December 10 and 11 event. Let's see what the European model, last night's European model shows an even stronger low-level jet surging all the way up to the Ohio River. That's your 0Z European model from last night. So this is a big problem, and your 850 low is further south. So in a lot of ways, this trough ejection is even more favorable for a substantial tornado outbreak than December 10 and 11. But it is pretty scary that this low-level jet is right over those same areas that were impacted by the December 10 and 11 trough ejection. This is going to be beginning the 2022 new year out here on January 1st. Basically a continuation of our very active winter. Here's 0Z as that low-level jet covers multiple states. The 0Z European model last night was still relatively progressive. And there is a possibility of some nighttime tornadoes on New Year's Eve from southeastern Oklahoma, northeastern Texas through central Arkansas as well. And that would be a New Year's Eve type of an event. As that low-level jet gets going the night of New Year's Eve. Let's take a look at about 10 p.m. New Year's Eve. And there's that low-level jet starting to ramp up, just pumping into central Arkansas. I'll probably be out here near the Memphis area waiting in position for January 1st. I don't want to chase the whole night, December 31st, and then tap out of my energy for January 1st, which looks like it's going to be an absolutely substantial severe weather event. But I do expect a late evening on New Year's Eve into the midnight hour, right in the nose of this low-level jet, and possibly even back into northeastern Texas. Certainly could see a nocturnal mode of tornadoes with about 500 Cape, a little bit of surface-based instability down there, a lot of moisture as well. That reservoir of dew points just sitting over the Gulf of Mexico. Look at these 70s dew points over the Gulf out ahead of this system. An absolute recipe for big problems on January 1st. But we still got to get through today. A lower end tornado threat, 2% zone out there. But look at this moisture starting to pump north on New Year's Eve out ahead of that system. That's at 6Z. Definitely could be some storms evolving throughout this warm advection regime, isentropic lift, some surface-based instability out there as well. Wind shear ramping up as we go through the night into the early morning hours. And I think different than December 10 and 11, this is going to be more of a daytime into the night as well. So I think this tornado outbreak is going to begin earlier on January 1st. And it looks like the European model is drastically underdoing those dew points. You're probably going to see dew points pushing 70 across that warm sector. The good news is that we are within the NAM as well. Let's see what the NAM has on January 1st with the shape of that upper system too. So here is the parent system with that positive tilt. We'll call that the parent trough. But there is going to be an embedded trough axis in here. Basically, that closed low gets picked up off Baja and surges out ahead of that trough. And then you get the squeeze play with that ridge over the eastern Gulf of Mexico and the southeastern U.S., helping to excite that strong low-level jet. This is at 21Z, and interesting that the NAM is much further north with that 850 low, which would bring the severe weather further north as well. But that is a weird shape to that trough. Well, this would suggest more of a bimodal type of an event with severe weather up closer to the 850 low, central Indiana into southwestern Ohio, northern Kentucky, and then some evidence of a southern mode down into central and southern Mississippi, stretching into Alabama during the overnight hours. This is at 0Z Energy Helicity Index, 0 to 3 kilometer layer. And your northern mode pushes into Ohio, and your southern mode continues to expand into the overnight hours. Evening into the middle of the night, definitely that nocturnal tornado event is going to ramp up across the southern mode as the northern mode gets pinched off. But the NAM is showing more of a bimodal type of an event, further northward extent of that instability axis. And that's because of that trough that gets picked up off Baja is much more progressive in the NAM model than the GFS. And that goes to show you just how complex this trough ejection is. When you have that tandem trough like that, picking up that trough off of Baja and then slingshotting it across the warm sector, timing is going to be critical. And if the timing is just off, then this event just simply won't go as big as it certainly could. So I'm going to be hitting the road now. I'm going to be working some of these flash flood warnings, some supercells that are able to peel off this line. I'm going to do a damage survey on that tornado that touched down near I-65 to the southeast of Birmingham. And I'm going to stay in position for that mega-trough ejection on January 1st. Thank you, everybody, for tuning into my weather reports and my live storm chases. I'm going to be going live here as I head back southeast toward that convective line. Never stop chasing.